Hi, this is Ziu. Today I'm going to do the homework 5, problem 1 of probability and stochastic processes. Okay, let's start. The first part of the problem 1 asks us to use the convolution method to calculate the Fz. So first we can simplify the formula of fx and fy, which fx equals to step function ux minus 1 and fy equals to uy minus 1. Thus, the convolution of fxz and fyz equals to integral from minus infinity to infinity fx alpha times fy z minus alpha d alpha. So expansion this formula, we can get this one, the new formula, and then we continue simplify the formula. Finally, we can got the fz equals to z minus z times uz minus z minus 1 times u z minus 1 and minus z minus 1 u z minus 1 and plus z minus 2 u z minus 2. Then we equal in order to get the answer of the original function, we shift the result to the right side by 1, and we will get the result for the original problem, which is that fz equals to z minus 1 times u z minus 1 minus 2 times z minus 2 times u z minus 2 plus z minus 3 and times u z minus 3. And the second part of the problem 1 asks us to use geometric approaches to solve the same problem. Again, we first simplify the question. So we first calculate fzz for z equals x plus y, with the fx equals to step function ux minus 1 and fyy equals to step function uy minus 1. So the big fzz equals to the probability z smaller and equals to z equals the probability of x plus y smaller and equals to z. And we separate the three parts to discuss the problem. First, when z is smaller or equals to 1, we can get that we can draw the graph like this. This line is equals to x plus y equals to z, and cross the z in x and z in y axis. So big fzz equals to probability x minus x plus y smaller or equals to z equals z power 2 power divided 2, and we can get that small z fzz equals to z. And the second part is when z is between 1 and 2, so we can know that big zz equals to this one, and we draw the graph of the formula like this, which the line x plus y equals to z across the square and across the x axis and y axis at the z. So we get the small fzz equals to minus z plus 2. And the third part is when z is greater than 2, we can get that big zz equals to 1, because whenever the z is the random variable z must smaller or equals to z. So the density function small fz equals 0, and we can draw the graph of the density function fzz like this. Finally, we shift the graph to the right by 1, and so we can get the answer to the original problem, that the density function fz equals to this formula. And we draw the final graph of the fzz like this, a triangle which at the point 1 and point 3 at the height is 1.